Hello. Happy Friday evening, day, Saturday morning, wherever you are. Hello. Thank you for checking in, Weetabix. And hello, Joseph, and hello, Beppo. Hello. I hope everyone's been having a good day. I've been having a good day. A busy day, but a good day. It's also been really cold. If you are on, like, the east coast of America, like I am, you can feel the coldness. Oh! I've been had! And it failed. Again. Thank you for the autoclave. Thank you. Have fun at work. Ripco. Bye. I agree. I'm not in America, but I woke up cold. Oh, yeah. I think it's just been kind of cold all around the world lately. It's been crazy. Oh, thank you for checking in, Ripco. Thank you. It's been freezing and also not a lot of snow here, but man, I know in some places the snow is going crazy. I saw, I think, reports in Canada, the snow is around 30 inches or 30, not inches, 30 centimeters, which is like quite a lot. That's a lot of snow. That's way too much snow for me. I've talked about how I think snow is great for a week or so. Also when you're not outside. If you're inside and you're just like getting a look at the nice snowy mountains growing outside, it's great. Wonderful. I like that. The moment you have to interact with it in any way, I don't want it. I don't want anything to do with it. Hi, Chris. Hello. Luckily, no snow here. Oh my goodness! Vanbino! 1,500 bits again? Thank you! That's so kind of you. Appreciate that. Incredible. I am very grateful for all you guys. I feel like I always talk about it whenever anyone supports, but you know, it means a lot to me. Thank you so much. So today's little sciencey, whatever you want to call this, is very casual and brief. I wanted to go a little more in depth, but I ended up not having as much time as I wanted to create my PowerPoint. So it's gonna be more casual and little laid back, and it's just cool science things I either remembered from 2025 or things I saw recently that I was like, whoa, that's pretty cool. Because there's so many different year end, like, this is what happened in science articles. And I saw them and I was like, that's cool. I didn't see that happen, but that's cool. It's actually really hard, I'll say, to find the super cool, interesting 2025, like, yearly science updates, because so much of it is like, as you might know, science doesn't just happen in one year. It's like, we've probably heard about this project for a while now, and it's just maybe now we're getting some cool results, but it's not like it's always completely brand new in this year. But you know, it's okay. Are we entering the quantum mechanics age? I don't think so, but you know, that's also not my field. I'm here in the biology space, so I can't say much about if we're in the quantum mechanics age. Maybe we are. I can just announce that we are, Joseph. Again, this is just stuff that I remember seeing or saw recently, and I was like, that's cool, and I'd like to share it with you guys. And I'll try to make it, like, easy to understand. A lot of it's not super difficult science, don't worry. I also think it would take too long to actually go into the science of each of these, as you would imagine. If they're super notable, they're notable for a reason, and we would have to do, like, multiple multiple like streams probably to actually go through all the background. Cool science hype? Yeah, cool science hype. And I feel like, you know, the first thing you gotta start with is what won the Nobel Prize last year in physiology and medicine. This one was, I think, pretty cool, but it's also a little, I know I saw people going like, I don't even know what the heck they did. And I think that's understandable. A lot of times, you know, you would think with the most prestigious prize, which is the Nobel Prize, like it would make it like, oh my gosh, the impact is crazy and super easy to understand. But you know, it's actually not that easy. It's you know, are you question marking? Why are you question marking, Josem? Is there a specific part you already don't understand? I barely said anything. If you're not familiar with the Nobel Prize, it's one of the most, I guess, like prestigious awards you can be kind of given by the Nobel Foundation. It's about things, your projects, research, whatever that have benefited humankind. How have you advanced humankind? So, I can try to break this down in like the simplest way to understand is there are immune cells called regulatory T cells, and they prevent the immune system from attacking the body's own tissue. And this is like a very, very interesting discovery that we have these immune cells in us. They've just kind of been chilling this whole time and we didn't really understand, you know, what they were. And I always think that's pretty fascinating that we still even have, you know, molecules and systems and mechanisms we just don't really get. I feel like sometimes non-science people don't understand that we really don't know everything in our body. We're pretty far from really understanding everything going on. And of course, understanding why, like understanding how the immune system doesn't normally attack itself is super big for things like autoimmune disorders, like, you know, arthritis and type 1 diabetes. And those usually involve your body or your immune system attacking the healthy cells. Oh, hello, Frost. We have really just started, and we started with what I feel like is, it's hard not to start with this, which is the research that won the Nobel Prize in physiology and medicine. And this has to do with regulatory T cells. Understanding that there's these immune cells that exist that help us prevent attacking ourselves, which is kind of like, might be hard to understand if you don't understand immunology. It will really like lead the path to new therapies. Like, how can we utilize these cells and make it so when we have disorders that cause us to attack ourselves, how can we like rework that mechanism? How do we stop attacking ourselves? I want to stop attacking ourselves. Very, 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 very important research. It's no surprise that this won the Nobel Prize. Because I think anytime you discover something new in the immune system, I think you're basically you're basically guaranteeing and gunning for the Nobel Prize. You're gonna make incredible influences in drug development and understanding better disease pathology. Always bigly. I tried to get a little bit more information about the research, but my goodness, it is quite a challenge to understand immunology research. And this is coming from someone who did a bit of immunology research. I did a bit of immunology research. There's just so many aspects of our human immune system. It's so complicated, as you would imagine, which is why we don't really understand how a lot of diseases still work. Even within knowing immunology, a lot of people are just experts of specific subsets of immunology. You know, like some people really only know certain cells that come with immunology. Like, some people are the B cell experts, or the T cell experts, or the macrophage experts, or the neutrophil experts. That was kind of what I was going through when I was in grad school. I went to the immunology department because I needed help with a specific part of my project, and they're like, oh yeah, I don't really know anything about B cells. And I'm like, but you're in the immunology department. Can't you help me with the B cells? There's B cells in my project, and I don't know what they're doing in my project. And yeah, it was really difficult to find someone like that had that level of expertise to help with a, thesis. At least for, of course, it's going to depend on your school's department. Some people, you might be in a school that has a whole bunch of B-cell experts. I kind of know about the immune system's capacity to choose a nuclear option for the body just to take down an enemy microbe. I kept hearing about it from other science channels. Yes, the immune system does, in fact, do its best to go, like, absolutely destroy the foreign invader in your body. So it will kind of throw everything and the kitchen sink to make sure that that foreign entity is bye-bye. And that can be a reason why you get the physical symptoms of being sick. A lot of times you'll be like burning up and you feel really achy and terrible and blah, and you just want to just lay in bed all day. It's because your body is throwing so much inflammation and other very harsh mechanisms to say, get out of here. Get out of here. Our body's not great with, like, how to say, like, nuance. Which is why when we have issues like autoimmune problems, it can feel terrible. Imagine your body is constantly just fighting itself. It's not even just a foreign entity now. You're just going, wha-bam, 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 to your own body. Did you know? I don't know too much about this, but I always hear this purported, which is our eyeballs are actually invisible to our immune system. And if our eyeballs ever became visible to our immune system, we would go blind because our immune cells would just attack our eyes. That's kind of funny, right? Okay, enough immunology. Let's get into some microbes. I've heard rabies can bypass most of that. Yeah, rabies does some crazy things to us. I'm no doctor, but it's not nice. I've heard that too about the eyes. Yeah, it's just funny. It's kind of crazy. Our eyeballs are just chilling, sweating every moment, wondering, please God, please don't attack me today. Don't attack me today, neutrophils. So, this was some interesting research I saw about how our gut microbiome could be protecting us, or not really protecting us, help manage symptoms of diabetes through improving insulin resistance. I heard a lot about our body going absolutely ham on anything that sees it. I wonder how our regulatory T cells work. Are our eyeballs invisible because of those T cells? It's a good question. I'm actually not too sure. This is something you can do such a deep dive in to really get all the granular information on. You'd probably also have to end up reading so many different papers because first you have to search, okay, I really want to understand how these regulatory T cells work, like what's their mechanism, what exactly parts of the pathways are they affecting, and then go into like, okay, now I want to learn more about the eyeballs. Why are the eyeballs invisible? And then, put the pieces together. I think it's a fascinating thing to look up, though. Okay. So, nobody's shocked, probably. The gut microbiome is crazy. It just does. Every time we feel like it's not doing enough, it's showing, oh my gosh, I can do even more, you guys. We were able... I am the gut microbiome. So researchers showed that certain molecules that are produced by the healthy bacteria that live in our tummies can actually contribute to reducing inflammation from high-fat diets. So if you don't know, when you eat a lot of when you eat a lot of fatty foods and sugary foods, you do, unfortunately, get a lot of inflammation. It's not great for us. That's why it's not really, really good for us. From my understanding, part of the bodies are restricted from the immune system, so maybe the eyeballs include that restricted area. I do believe that the eyeballs are part of that restricted area. I cannot tell you exactly the mechanism of how that happens. I am sure it has to do with whatever is coating the surface of those specific proteins that make up those organs and parts of our body. They must be able to pretend, like, give us, so to say, like, invisibility cloak to our immune system. So these bacteria, the molecules they produce, they can kind of help reduce inflammation. And this is huge for figuring out maybe this can help manage more diabetes. I thought it was just fascinating. I'm a huge gut microbiome fan, if you can't tell. I love reading research about what the bacteria in the gut are doing. It just seems to be more and more information about we're basically controlled by our gut. The little ball of bacteria in our gut really keeps us healthy. Our real life symbiotes. Yeah. I like every year, especially, I think more and more interest is being put onto the gut microbiome. We can't stop finding how our gut microbiome has been protecting us. And it just shows you we really need to, like, figure out more answers of how do we maintain healthy gut microbiome. Till the C. diff goes wild. Yeah. We have to figure out more information, I think, on, like, properly maintaining it. There's always, of course, diet and taking supplements, etc., etc. But I think if we could better manage that, it would kind of go crazy. And also, I think understanding the why certain percentages, like what's the maximally greatest wonderful percentage of our composition for a gut microbiome. It's really, really complicated. I really wanted to do this kind of research when I was in grad school, but it's really hard to find. It was really, really hard to find a school that was looking for, you know, students to do this, which was unfortunate. Sadness for me. A new phylum of microbes. This was really cool. This is also, there's like way more research related to this. There's so much other things. So if you don't know what a phylum is, it's the categorization of bacteria. So they dug into the dirt, deep into the dirt. Deep into the dirt, and found this super ancient, previously unknown phylum deep underground. They're called the CSP13 bacterial phylum. So they said they found this in the critical zone, and that's the layer where the soil, rock, air, and water interact. So it's kind of like everything's the avatar of the soil layer, like every element's kind of like dealing with something there. And so it was a crazy discovery because it showed they were able to find that these bacteria play such an essential part in the ecosystem. They were able to show that this bacteria is part of nutrient cycling and water filtration. So we were benefiting from these little guys all of this time, and we didn't even know about them. So cool. All because we just dug in some dirt. I think there's also a lot of, this is when you lose me a bit. You lose me just a bit because I'm not the best evolutionary geneticist understander. But it does, I think there's theories apparently of how this might relate to life originating and then the diversification of Earth. They were able to map things out because of how old these microorganisms are. That's so cool. I know. How is it just in the dirt? We've actually been doing, I'm say we as in scientists. They've been doing so much soil research as of late in microbiology because there's so many different microorganisms and little guys in the dirt. They're all in the dirt. They've been looking for so many. I think I read, I'm not too certain on this, the tools they used to use for examining bacteria in the soil were not very good. It was pretty inefficient to actually search through soil and try to figure out what's actually in here, especially when you start going deeper in the layers, which is why this research is is new. But now that technology has gotten so much better and they've been able to do things like finding a whole new phylum of microbes, and then also they're doing a lot of investigation on antibiotic resistant bacteria that could be in the dirt. There's just so much. There's so many little guys we don't know about, you guys. I've heard how some deep underground bacteria live for very, very long. Yeah, I mean, they're chilling over there. They're perhaps, who knows how old they are. They could have been here since the Earth was just a wee little rock. What this makes me think of is we've known a lot of functions that are being done within dirt. So like if we identify these microbes do X, what was previously misattributed with its function? I think usually, in the case of, we did know that nitration fixing and nutrient cycling and water filtration has always been something we've known about. I think it's mostly not just misattributing. I think the things that they identified that do participate in those functions did do those functions, but I think it's more like, oh, there's other participants in this. There's other guys. They're not working alone. They're not here by themselves. They've got some friends that we just had no idea. Especially, like, I would say we attributed a lot of things to fungi. Fungi has been not surprisingly, they do a lot of the similar function, and they are way easier to like identify because they're kind of on the topsoil compared to being all the way down here. But knowing that there are other players in this function, it's always good. Always good. Okay, the next one is very outside of my realm of really understanding, but I saw the news title of it and I thought it was just funny. And I saw the picture and I thought it was funny. 3D printing in cells. So they 3D printed very, very, very small microstructures inside of live cells. And one of the examples they gave was they 3D printed a 10 micrometer elephant right into a live cell. I'm gonna expand this a bit. Can you see that? That's an elephant. They put that elephant right into the cell. And it's so funny looking. It looks just like the elephant. And the crazy thing is, this didn't kill the cell at all. They were able to 3D print it with these, like, I think it was just, it's like, you know, laser 3D printed. It's smaller than a red blood cell. He's straight vibing in there. I know. It just lives with an elephant inside of it. Are they gonna make animations with them next? I don't think. I don't know what their next plans are, but I think they talked about how they have. This is a kind of a proof of concept, more like it. They don't really have much intentions, it seemed like, of what the applications are, but it's like, well, you can do this, and you know, another research group can do something cool with it. Maybe, who knows? Like, I think some applications they had in visions were, what if we can put a sensor right into the cell? Like, if we can make a 10 micrometer sensor, and then you can really monitor how the cell moves, divides. while not being dead. That's a very important part. You don't... It's really useless to study a dead cell. You really want to study a live cell. What was it made of? That's a good question. I don't actually know. 3D printed... I can't remember. Let's see. Oh gosh. It's so hard to... Why is it so difficult to find this information? Additions prepared to the blah 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 blah. I don't see anything specific about what it was made out of. It's definitely cell manipulation is a big thing right now, even with CRISPR trying to change their DNA. Yeah, cell manipulation is like the huge one. They really want to know how to manipulate cells, and this is a big application for it. Understanding directly how a living cell is perhaps influenced or can be modulated, it's a huge application, huge application. Little elephant may be funny, but it's got huge implications of future therapeutics and research. I think this has applications for micro robots. Maybe one day we will all have little micro robots in each of our cells. I don't think that's gonna happen, but you know. I really like the elephant. I truly love this guy. I wish for a little elephant in all my cells. This next one is also an example of... That's pretty cool. Dental floss vaccines. This was like two parts of coolness for me. First was the methodology. They had to figure out, how do we test this preclinically? How do you floss a mouse? And that was a huge part of their paper, was trying to figure out, how do you floss the mouse? And apparently it's very difficult to floss the teeth of a mouse. Very, very difficult. They said it's like a two-person job. One, has to hold the mouse, and then the other one has to kind of get in there and do the flossing. Apparently it's called an unpolymerized photoresist that was inserted as a fluid and eventually hardened. Ah, okay. I think I saw that, but I didn't internalize that was the material. My brain was like, that just sounds like adjectives used to describe a material. But makes sense. I would never thought of giving vaccine delivery through flossing. That's also the part that I just thought was fascinating too. Using the floss to deliver vaccines is kind of a genius idea, because the skin, the membrane of our gums is a great blood, like the blood barrier it's a huge, super easy access. So instead of the needles, they would put the vaccine material right along the gums. And so when you floss, your tissue is super thin and packed with immune cells there. And so when you would, break contact with your gums, your immune system would likely instantly recognize it and start building protection right away. All without breaking the skin compared to like a traditional needle. Comes off similarly to me too. I'm looking further to see if there's some kind of photoresist they use. I don't know yet the material is. Yeah, I think it would be easier if I got the paper. I have to see. People would much prefer this over a poke. Yeah, I think this is something we really need to unfortunately explore these options, because vaccine hesitancy and, people being scared of shots. I think anything to kind of overcome those barriers are huge. I think that's why, we were trying to go for things like nasal spray, but I think the nasal spray vaccine administration hasn't been super popular. This would be kind of an interesting thing if you can just tell someone, hey, can you floss? Can you do this with your can you just put this floss in your mouth and then you're good to go? We'll see how this is, like, the efficacy. Like, does it provide the same level of protection? And is it actually, you know, doing is it even close to a shot? If it's not, we just have to see. Unfortunately, you know how it is with mouse studies. Sometimes things look good and then it doesn't exactly turn out the way you want it to be. A very interesting proof of concept. I'm curious to see how this goes. I would prefer a floss, I'll be honest. I don't even mind shots too much. I get my yearly flu shot and it's just a little poke, but it's not pleasant. Most likely you'll have to do it often and then wonder if the patients if they miss a day, will it still be effective? Yeah, I think there will be a lot to see from this. Like, how often does this need to be done? I have a feeling it wouldn't be as a yearly thing. It would probably have to be a lot, like, you know, many times. Like you said, like maybe every so often. Maybe like you give them like a week of this, and they have to floss every week, every day of the week. That might be a lot to ask for, but we'll see. People are very creative. I think the coolest thing about this is just the creativity of trying to solve some of these issues. That's what science really is, you know? You want to be creative. It's one of the most creative professions out there. You see what other people have done. You see the stones they've laid out, and then you go, well, what if we do this thing instead? And that creativity, I think it can be really hard. I consider myself a creative, and when I was in grad school, I feel like it was a struggle sometimes, because you really have to be not just creative, you have to be knowledgeable. You have to know what's been done, you know? And it's a challenge. There's also the third odd thing of it needs to have feasibility. It has to have some kind of, like, we have to throw money at something that actually does work. And sometimes I was bad with the third one. Sometimes I was like suggesting things that perhaps could never be done. But you know, dreaming. Let's see. Okay, next one. A new organelle. This is also up there with like, wow. How does this happen? I think, again though, preface. As I said, sometimes research is not just all. It's not all of a sudden this discovery has been made. This has kind of been hinted at and talked about for a while, but it's only recently that I think a lot of articles and publications and other researchers started picking up on this. So a new organelle has been identified in our cells. It's called a hemifusome. IPS photoresist. Oh, is that the name of the material, Frost? Interesting. Again, I think the material engineering is not my forte, so it was difficult for me to parse through that paper. But yeah, I will believe you. I did see the word photoresist. So this hemifusome, it's not that we didn't know that the structure magically appeared in our cells. It's more like we knew that there was this structure in our cells and we didn't really know what the heck it was. It was just kind of like there. So I tried my best to explain it. I couldn't really get the full grasp on it. So it helps with membrane merging and separation inside the cell. So, you know, cells are kind of constantly moving, and they use little tiny membranes, bubbles. They like move around, and they And for that to happen, the membranes kind of need to fuse together in a really controlled way. So this hemifusome, it's like kind of like the temporary in-between organelle that forms when two membranes partially merge, but they haven't really fully combined yet. And so this was, you know, they were able to identify this by looking at the cells while they were moving, and they imaged it, and they were able to observe the process that was predicted for super long. This has been like in the works for a long time, but they've never been actually able to see it in a living system. Again, this plays a huge part in understanding how cells move and how they move around and modulate and communicate with each other and maintain organization and structure. Normal cell function, you know. Sometimes basic biology can be super groundbreaking. It's just really hard to find those groundbreaking studies nowadays because, first of all, a lot of basic biology has been done already. Who would have thought? We've already found a lot of things. But also another big problem is there's not a lot of money. There's not a lot of money involved in basic biology science research. You're gonna be a little hard pressed to find someone that wants to fund you to look for something that's happening in a cell that doesn't have an exactly, a therapeutic outcome associated with it. There's no like exactly a money maker. Where's the money maker? This leads to a moneymaker, like perhaps this can be, looked at and figured out, well, how can we therapeutically target it in some way? How can we modulate this organelle? How can we take advantage of this mechanism, et cetera, et cetera? But on its own, it's like, well, what do you want me to give you money for? People fund outcomes, not research. Yeah. And even when the outcomes, this is an amazing outcome to be able to capture something that's been long predicted. It's still not, it's difficult it would have been very difficult, let's say, for a small lab to say, I'm here to study this. I'm here to study this thing that's been predicted. You probably aren't doing that. I think basic science research is so interesting, though. I kind of got... I was a little disillusioned in academia, so to say, because I just loved figuring out the basic science and basic biology. I just want to know why things work the way they do. And it was really hard to... it's really hard to get to find labs like that. Really hard. But that's okay. I'm here now to like look at that. I'm here to look at other people doing that now. I don't need to be involved in it to get the satisfaction. I can just look at other people doing it and go, that's lovely. That's cool. Thank you for discovering the hemifusome. I'm not even sure if I'm pronouncing that right. Hemifusome. Okay, this is the last one. And I think this one was super popular on social media, so you probably won't be surprised to see this one. But the de-extinction genetic engineering project by mostly Colossal Biosciences, they were able to genetically engineer DNA, and they quote unquote brought back extinct animals like the woolly mammoth and the dire wolf. This is incredibly cool to me. I know there's like some other concerns involved, perhaps with the company's ethical stances and perhaps the ethical, moral dilemmas of calling this a de-extinction when it's not really a de-extinction. They were able, if you're not familiar with this company, Colossal Biosciences, they were essentially genetically engineered to recreate traits from extinct animals. And those extinct animals are, I think, primarily they focus on like the woolly mammoth and dire wolf. Or at least, I think they have more extinct animals they focus on, but these were the two that really had a lot of news and coverage because they had actual results, like this very cute mouse that has the woolly mammoth genes, quote unquote. I think a lot of people misunderstood this as they were cloning the animals, and there was a lot of science misinfo going around when they were talking about, like, when the social media outlets were going crazy with this, there was a lot of, like, weird science misinfo going around about how, oh my gosh, the woolly mammoth is coming back to life and it's cloned. They cloned it, they took it from the iceberg, they, like, picked it right up and it's back. It's walking the earth now. But that's and they also made it a mouse, and that's not really what happened. They really just took DNA, I believe, of the closest living relatives, and also some preserved remains, I believe, and then they inserted that into the closest living relative. So in the case of the woolly mammoth, they took the remains, and I think they inserted that into modern elephants. And then they controlled certain traits like thick fur, fat storage, cold resistance. This was mostly done with CRISPR-Cas gene editing. Less Jurassic Park, more like a sci-fi chimera. Yeah, like, it's definitely no Jurassic Park. We're incredibly far from all of a sudden having a Jurassic Park. But it's just like, it's just gene editing. It's very cool. I'm not gonna lie, I think it's cool, and it's resulted in such cute things. I think this mouse is so adorable. It's incredibly cute. It's so furry and fuzzy and lovely, and I want one. But it's no woolly mammoth. It has genes that kind of resemble that extinct species, but it's not really that. Genetic reconstruction, chimeraing. Even the wolf is pretty cute too. I mean, it does give like a dire wolf, but it's not a dire wolf. It's not a dire wolf. And I think, yeah, I know there's been a lot of talk about how perhaps this isn't, like, why are we doing this? Are we crazy? I think it's interesting to see how you can push things like DNA editing. So I don't blame these companies. And obviously there seems to be a market. I don't know if what they're doing with these animals, but I think they get a lot of venture capital funding. And also, I mean, they made so much social media noise. I wouldn't be surprised if people want to invest in them, because look how cool. Every time they release something, it's making headlines everywhere. I'm curious about how they're gonna go about this next. I'd like to see their next steps, and also if they have any plans to make the woolly mammoth not in a mouse form. But we'll see. I just think it's more interesting more than anything. I think in regards to the application of the other science things we've talked about versus this, I feel like this might be lower in like future scientific advancements, but that's just me. I'm also heavily biologically therapeutically biased, and this is less in my ballpark, just so to say. Yeah, I remember the direwolf thing came out. So I read it's not a historically accurate direwolf. More so, they used direwolf genes to make a gray wolf look like the fantasized version, since the closest living thing to it would be the maned wolf. Ah, yeah, I do recall reading that too. Again, it's a very interesting project. I don't even think they're the only ones doing it. If I remember, I read there's other companies even trying to do similar things. So it's not like this is incredibly novel, but it's clear that Colossal Biosciences have gotten, I don't know, they're the de-extinction guys now, because were able to make two big cases. Oh, I've seen these. Yeah, I figured this was something I remembered from last year that I was like, that is fascinating to see. Things I don't have a PowerPoint slide on because I didn't have more time to talk about, and also it was difficult to really put this information together. I think another huge 2025 science advancement is has to do with a lot of like AI applications into science, like into the medical field. I don't know if I want to call it cool. Some of the applications are, I think, interesting. And then I didn't put it in mostly because I was like, I feel like then I also have to talk about the bad implications. And I was trying to keep this lighthearted. There's also some not good applications, or more like, it's not like not good, misused applications of AI in the medical field. But that can be a whole stream on its own. Regardless of country, I think this stuff can help with animals that are endangered. Yeah, but it's also an issue of, it's also a topic of, well, it's not really exactly the same animal. It's kind of just like a re-engineered version of that animal, so to say. So is it really helping them with animals that are endangered if like we'll never have the exact match of that animal again? Or maybe they'll get there. Who knows? So those were my top 2025 science news. And mostly, of course, this is all mostly in my realm of science topics. If we went through all the cool science, I think it would be very, very, very long, because I think a lot of fields that I'm not too familiar with made super crazy headway, and I was like, I can't understand what you guys are doing, but I am sure you guys are doing great things. Like, I saw some crazy cool physics stuff and like engineering things, and I was like, you go, guys, you do it. You make that thing. You make those materials, and you find that space thing. It was a little over my head. Whoosh, whoosh. If you guys like know any cool science stuff that happened in 2025, or even as it's happening now, if you ever see anything cool, please post it in my Discord. I love seeing that. It's so hard to keep up with everything because there's just so much science news. One of my jobs, and my sciencey science job I do when I'm not a bacteria VTuber, is looking at what's happening in the cancer science space. And I have to read like you don't know how many articles I have to read every single week, because every week there's just so many new articles that happen in the cancer science space. I run into so many cool things, but I just forget them. You just slam dunk them into the Discord, and like if you see it, just slam dunk it. You don't even need to really know anything. If you think it has a cool title, you just go whoosh, go. It's not like it's your research, and you don't have to stand by it. It could also not be the greatest science, but we can figure that out together. Plus, I don't want to spam my friends, so I tend not to share things since I don't want to be a bother. The beauty, I like seeing the science things. I appreciate you, Frost, when you send me cool science things. I like that. You're also free to just post them in our Discord. We have a whole channel called Science Media, and Science Media is just throw anything in there that's sciencey. I heard of a few cool developments in sustainability. A university in Japan claims to have discovered a plastic that fully dissolved in salt water within 3 hours, so no more solid waste or microplastics. That's fascinating. I think when I was looking up cool science stuff, I literally Google search cool science in 2025. There was a lot to do with addressing the plastic waste problem and environmental issues, which is no surprise. That's a huge concerning issue right now. And I think I saw something about that research. I was even gonna... There's been already so much things about, trying to get rid of forever chemicals, make them unforever. Such a huge problem. It's always interesting seeing how so many people are trying to tackle these issues with microplastics, plastics, and all the toxic waste in our environment, but it feels like it's a never-ending problem. But I am so glad to see that there's trying to be headway into this. I think the issue, what I've seen, especially when I've seen articles about, like, let's say bacteria that eat plastic, I think the scalability tends to be the big problem. Of course, I'm no sustainability researcher or even expert. I'm not even anywhere close to being one of those experts. But I think a big problem tends to be that we have these cool bacteria that can eat plastic, but they like eat a tub of plastic in like a day. And we've got many tubs. many tubs of plastic to get through. It's definitely a big issue, but I also mean there's several different groups all trying to tackle from different perspectives. Yeah, that's a great thing. Even in science, in biology, like there's so many. How many different research groups are trying to tackle all the different types of cancers and diseases out there? We all need to tackle these problems with like so many different solutions, because there's probably going to be not really one exact answer to solve these complicated issues. I love science. Wish we worked together more. I think that's one of the big problems. I don't know about other fields, but I know biology has a problem with not wanting to work together. Sorry, I'm just drinking water. Gosh, I feel that so hard. Yeah. That's all I can say. Yeah. Every research feels like competition in the comp sci research space. It's such a tragedy. I know a few people that are in the comp sci research space, and they've talked about that too. It's very competitive, but from what I've heard, I think a lot of science research fields are getting like this. It's becoming quite, I don't want to say oversaturated, but it is quite saturated. There are so many researchers and scientists out there now, and there's not enough money is a big problem. There's just not enough money to fund all this research, and so people are getting even more competitive. I think most of the issue with plastic is economy. It's more cheaper to produce new plastic rather than recycle and use other types of plastic. So for the plastics issue to be solved, the economy stuff is involved. Yes, you're right, Joseph. It's all these issues are always intersectional, as in it's not just solving one problem. You have to solve so many other aspects. You have to figure out why this issue is even happening. So very good point. Very good point. When it comes to plastic, it is, I think, a big problem of usually this waste. The cheap stuff you throw out is quite affordable compared to the long-lasting things. And, you know, how do you tell someone to stop buying the really cheap stuff when that's all they can afford, even though it, like, degrades and it has to be thrown out so fast? I think that's like one example of like fast fashion, if you're familiar with that. There's companies that really produce clothing that feels, I think, like 99% plastic, and they sell like shirts for $2. And how do you tell someone, please stop buying the $2 shirt, when the $2 shirt is maybe all they can afford, even though the $2 shirt is gonna break apart in like a week? Who would have thought? Things are complicated. I truly like the little mouse. Hold on. There was a VTuber that was based off of this, like, mouse. I think they were very short-lived, though. But I really like it. What a cute guy. Okay, I have to head out because I want to do some late night grocery shopping before the grocery stores close. And I also want to leave before the ad break starts. The most closest word similar I've heard is planned obsolescence. Yeah, that's a good term. I think that does happen a lot. Especially when it comes to technology, like electronics. That's terrible. Terrible that we throw away electronics so, like, in a year or two. Thank you for the stream. Thank you guys. Thank you. I will be back tomorrow, and it will be just like a yapping and playing some, I think, 2-Point Museum, which is just me decorating a museum. So I'm just gonna be prepared for more yapping. Okay, I will see you guys later. Bye. Thank you. Check out the Discord if you haven't. Bye. Bye.